my name is Prerna Rana. I would like to welcome you all for today's session on behalf of whole Study 9 team and put some light on today's session. So, containers are very powerful technology. It has tremendous impact on transforming IT industry the way it does what it does today. Today we'll talk about all the details about containers and Docker's technology. I hope you all are excited to learn about containers. So without wasting any further time, let me introduce our instructor, Mr. Santosh NC. He is a corporate trainer and instructor at Study 9. He is lead DevOps engineer and having a total working experience of 8 years. During this time, he has helped several professionals and teams to understand different DevOps processes and tools. And in today's webinar, he will do same for you. He will explain everything that you need to know to hit the ground running when it comes to containers and Dockers. If you want to ask any question, you can ask in comment section. It will taken up in the end of session. So sir, over to you now. You can take care of the session.
Thank you. Yeah, thank you, Pranav, and good morning. Yeah, so am I audible now?
Yes, sir.
Okay, yeah, thank you. So, good morning to each and everyone, and really thanks for joining this particular session or particular webinar on Docker in this weekend. Okay, so like it actually like gives on it acknowledges your learning experience and your learning quest towards the Docker. And in this particular webinar, and we are going to see about this Docker, and Study9 has handcrafted this particular curriculum or the syllabus for this next 90 minutes, so purely in terms of the real-time experience or in the real-time implementation phase. Okay, so this is not going to be a kind of like theoretical lecture, so we are going to have a lot of things like in terms of your what is it, I mean in terms of your hands-on and real-time hands-ons or more comparing to the theoretical lecture. So I'm just like jumping into that. I don't want to like waste your time. I'm just like jumping into that. And if you're facing any issues in the audio or in the respective what is the screen sharing stuff, so please do let me know, or please do comment in the comment section so that like the team will take care of that. Okay, so yes guys, let's shift the gears, and I'm just like starting for this particular day. So this is the agenda for this particular day. So first we are going to talk about this fundamentals of virtualization and containerization, then introduction to Docker and the Docker under architecture, and this Docker demo and the hands-ons, and finally you will be having the Q&A section at the end of this particular thing. Okay, so without waiting for some time, so I'm just like jumping into that. So initially, what is meant by this virtualization? Because this virtualization is the base for cloud computing as well as for this containerization. Okay, so if you understand this virtualization, so then we can like go for this, I mean we can easily understand the cloud computing or the what is it, the containerization. So basically the virtualization means it is simple, like okay, I cannot take the pinpointer, I mean I can take the like presenter or the laser screen, but let me follow this particular the hand or the mouse pointer here. So in this particular virtualization, so what we will do means the basic hardware will be there, the basic hardware will be there. So on top of that single hardware, we will be implementing or we will be creating multiple virtual machines in order to work with. So that is the basic concept of virtualization. So guys, I'm going to showcase a real demo for this virtualization, so within a short time. Okay, so which means I'm just like reading some of the points here, so which are all the important points. So it is useful for creating the IT services using the resources that are traditionally bound to the hardware. So the hardware will be the single one. On top of the hardware, if you see this particular one, the hardware will be the single one, but on top of that you have implemented a virtualized layer, and on top of that you are having multiple operating systems. So see, I mean we are having around 6 operating systems instances, but it is the single hardware there. Okay, so using the single hardware, actually you are doing all these things here. So that is the basic concept of virtualization. So the second point would be, which is more important, means like it is allowing us to use the physical machine's full hardware capacity by distributing its capabilities, okay, by creating multiple VMs. So the same point I'm trying to convey. So your single hardware will be there. Let us say you will be having this 16 GB of RAM. Let us say for an example 16 GB of RAM. So if you implement only one machine on top of that, that machine will entirely, what is this, I mean, bring up all the 16 GB, but it will be a like waste of memory or waste of resources. This is not the effective utilization. But on top of that particular 16, you can split 2 GB of like each for each and every operating system. So that will be the easiest one, that will be the efficient resource utilization. So that is the purpose of this virtualization. And here these are all the technical terms. So the virtual VM, okay, so a virtual machine is a concept that we are going to run here. And what it will do means it will scan, or it will bring up, or it will use the, or it will create its own CPU, memory, network interface, and the storage based on the host operating system. And the most popular VM providers are VirtualBox, it is an open source one, and VMware, yes, you need to pay some license amount for that, and the Microsoft Hyper-V. In addition to that, actually we are having multiple VMs, multiple VM providers as well currently in the market. So this is the basic concept of virtualization. So now it is my turn to showcase a simple demo in terms of the virtualization. So how we can do the virtualization kind of thing. So just give me a minute, guys. I'm opening my machine. Okay, I'm opening my machine. So let me share my screen. Okay, so that like you can easily understand that. So I'm going to share my virtual machine for your understanding, or I can share the entire screen for you. So for the better understanding. Team, I hope like my screen is visible to everyone. Yeah. So if you see, this is the virtualization technique that I'm using in my machine. If you see, my machine is a Windows machine basically. So in that Windows machine, I'm running 5 machines on top of that. So Minishift is based out of Linux, and Ubuntu. Yes, you are already aware of this Ubuntu, and this Ansible controller and Ansible target. These are all 2 machines based out of CentOS, and this Minikube is once again based out of Linux based operating system. So on top of the single Windows machine, I am able to run 5 VMs. So using this VirtualBox, this is the concept, or this is the real-time implementation of the virtualization. So now I'm going to the second topic here. I mean, sorry guys. Okay, yeah. Now I'm going to the next topic. So what is meant by this containerization? Okay, so how the containerization differs from the virtualization? Okay, so in terms of this containerization, it is just a unit of software with the respective application code, runtime, and the system tools, and the system libraries, and the dependencies. If you see the, we are going to see the difference between this virtualization and the containerization. But for the better understanding, you just like keep this in mind. This container is a simply a software. Okay, this is very similar to virtualization, but this is in terms of the lightweight, you can consider this as a container. Okay, and this containers will contain only the application code, the runtime, and the required system tools, and the required system libraries, and the dependencies for that. And in addition to that, how we will be creating this container means based on the container images. So in terms of virtualization, we will be creating with the help of operating system images, but here we are having the container images. So these containers are nothing, sorry, these containers are nothing but it is just like a process. Okay, it is just like a process which is running in your machine. So we will be having a lot of processes, right? For example, if you run in terms of Linux, if you are aware of Linux, so all these things are like based out of the processes only. So these containers are something similar to that. So yes, please understand in the theoretical perspective, then like we can get into the respective demo. And if you see this particular image, so you are having the infrastructure, which means the host image, I mean the host operating system and its own infrastructure. On top of that, you are installing a containerization software, which means the Docker. And on the top of the Docker, you are able to find only the applications, app A, app B, app C, not the operating systems. So that is the beauty, or that is the basic difference between the virtualization and the containerization. So the container providers are Docker, Rocket, and LXC, so Cryo. So we are having a lot of container providers, but in this session it is purely bound to this Docker one. And these are all the basic benefits, guys. Okay, these are all the basic benefits, I mean the common benefits that you can achieve with the containerization. So the first one would be the portability and the platform independent. I mean you can run it in any platform. It might be Windows machine, it might be, what is it, it might be a Linux machine, it might be a what is it, Mac or Mac based one, so you can run it anywhere. And efficient resource sharing, so these 2 points. So you can efficiently share the resources of your host machine by restriction. So you can employ the restriction, you can get the efficient, I mean you can get the required resource in order to work with. And the speed, one of the main and the most important concept is speed, because VMs will take some time to up and running, but Dockers will do it in seconds kind of thing. And the container isolation, so if you see this particular image, so this app A and app B, so both are isolated in nature. So app A cannot interact with app B, so app B cannot interact with app C. So this isolation is in the, I mean in the respective place. And the high scalability, so you can easily scalable this containers to the multiple hundreds and thousands of replicas within a single command. And improved developer productivity is, you are going to, the developer can easily interact with the Docker. So if you guys are like working on a Java or Python or as a developer in any language, you can easily work with this particular tools, I mean particular Docker. So that is the concept here. And guys, this is the common difference between the VMs and the containers. If you see, the VMs are exactly heavyweight. So why heavyweight? In the sense, it will be using the operating system as the base. So in operating system you will be having all the details, all the kernels, like each and everything will be there. But in terms of containers, it will use the kernel of your host operating system. So which means you don't need, or there is no necessity of extra operating system on top of the host operating system. And here we are having the limited performance, and in terms of this containers, it is based upon the host operating system. So this is the main point, guys. So each VM run in its own OS, so that is the main point. So here all the containers will share the host operating system. So this one is at the hardware level virtualization, but this containers are at the OS level virtualization. So the startup time is in minutes, but in terms of this, what is that? In terms of these containers, it is in milliseconds. So that is what I told. So it will take some minutes to up and running, but in terms of Docker, it will take only some milliseconds. And here you will have, or you need to, what is that, I mean you need to give a lot of memory for this, but containers will require only less amount of memory in order to go with. And here it is fully isolated, so we can consider this as a secured, because like we will be having some different, so what is that, different set of operating systems will be running there. But in terms of containers, being, I mean using the same host operating system, if anyone hacks the host operating system, so they can enter into the respective containers. So that is why like we are having less secured when compared with the VMs, but we are having the respective security technologies there in the place in order to restrict this. And guys, this is the simple difference in terms of the image. If you see, in terms of Docker, I mean the one which you are having the right side, it is purely aligned with this containerization, and the right side, if you are seeing, it is with the virtual machines. So if you see this particular container, you are having only the Docker here. On top of that, you are having only the applications, not the operating systems. But at the same time, if you see the virtual machines, you are having the infrastructure. On top of that, you are having the hypervisor, and inside the hypervisor, you are having multiple VMs with different set of operating systems. Guys, this makes the exact difference between the virtual machines and the containers. So please understand here. So now what I'm going to do is that I'm going to start with the hands-on portions. I mean, not the hands-on portions. So we are going to getting into the respective Docker thing. Guys, if you are having any doubts like till this particular stage, please feel free to post that in the respective chat, I mean comment window or the chat window, so that like we can just like check it out at the end of the QA session, I mean at the end of this particular session. So what this Docker means actually, okay, what is why we are having a lot of hype related to the Docker. So the thing is that it is the most like the famous tool, so for developing, shipping and running the applications. So it is the logo of the particular Docker, guys. This is the logo actually. So it is a whale. So on top of that whale, if you see, we are having a lot of boxes. So these are nothing but the containers. So which like how Docker is performing this developing, shipping and application means using then isolated environment called container. So using this Docker only, we will be going to create the containers at this particular stage. And guys, this is the simple architecture of this Docker. Okay, so how we will do means the client, in the sense we are the clients. Okay, so the Docker client means we are the clients. So what we will do means we will initiate the request from the client side, and it will go to the Docker host. So in Docker host is nothing but the Docker server machine, and this client is nothing but the Docker client machine. So from the client, the inputs, I mean the request will go to the Docker host or the Docker server. So inside that, there will be a process, there will be a running process called Docker daemon. So this daemon help us to will help us to process the request. So this daemon will get the request, and it will look for the images, and from that images the containers will be created. Guys, like please understand the flow here. So from client, okay, from client, the I mean it will, okay, let me uh, okay, yeah. So cool. So from client, so you will be initiating the request, and it will go to the Docker server, which means the Docker host. So inside the Docker host, so Docker daemon will get the request, and it will check for the images. So if the images is not there, it will bring it from the Docker registry, which is nothing but Docker hub. So it will bring the images from the registry, and from that particular images it will create the containers. So guys, this is the simple architecture of this Docker. So we have discussed about this Docker daemon. So Docker daemon is nothing but your what is it, your process which is running inside the Docker host or the Docker server in order to respond to your requests. And Docker client is nothing but your client side approach. So we will be interacting with this Docker client only. And Docker host is nothing but your Docker server, so where you will be having this Docker daemon running. Guys, this Docker will work in terms of the master, I mean master slave or client server architecture. Okay, not the master slave, it will work in the client server architecture. And finally, we are having this Docker desktop. Actually, this Docker desktop is an option to install Docker in the Windows based machines. Okay, if you are using the Windows based machines, you need to go with this Docker desktop for the installation. And Docker registries are nothing but, here you will be having the set of images. Here you will be having the set of images. In the registry is nothing but the place where you will be having lot of images. So here The Docker registry is nothing but Docker hub. And under Docker objects, you will see one thing is images and one thing is containers. So guys, for operating system, for in order to create the virtual machine, you need the operating system, right? Hope you are clear in this particular point. But in terms of your containers, you need to have the images as the base. So from this image only, we are going to create the containers. Guys, don't worry, we are going to see the commands and the working nature of each and everything. And Docker networking is nothing but you need to expose your container to the public internet, right? So that is what actually we are going to see in this Docker networking. And the next one would be the Docker storage. So we are going to use this Docker persistence, right? So we are going to use this Docker storage option in order to perform that. Guys, don't worry. So we are going to see the hands-on thing for each and everything. Okay, so for Docker images, Docker containers, so for each and everything, we are going to see the what is it, the exact hands-on perspective. So if you are having any doubts regarding this Docker architecture, so please post that in the comment section. Okay, so now it is my work to start with the hands-on portion. Okay, so now we are getting into this hands-on, guys. So like now what I'm going to do is that what I have done is that, okay, okay, so now I'm going to like put this, I mean, going for this particular hands-on, or so just give me a minute, or I can take the questions. Like Veeraj posted one question. So what is the difference between Docker daemon and Docker client? Okay, so Veeraj, Docker client will sit in your own place, so where you will interact with the Docker client. So this, after getting the input or after getting the command from your end, so this Docker client will push your request to the Docker server or the Docker host. So inside the Docker host, there is a process, there is a running process called a Docker daemon, which is responsible for responding to your Docker, I mean, which is responding to your client requests. For example, you are giving this Docker build. Okay, let us say this, there is a command called Docker build. So this Docker build, you will type this in the command prompt or then the CLI. So this Docker build will hit an API request to Docker daemon. Then the Docker daemon will work based on the API request which you get. So for example, this Docker build means in order to build the image, so it will take the API request and it will perform the respective steps and it will reply back with the your output, the exact output. So this is the basic difference between the Docker daemon and the Docker client. Yeah. Okay, guys. So what I'm doing is that, so the first demo which we are going to see for this particular day is regarding the installation of Docker. So how we need to do the installation of Docker. So guys, for this particular perspective, so what I did is that, okay, just give me a minute. I'm just like closing all these things. Yeah. So what I did is that I created an EC2 instance based out of Ubuntu. Okay, so I created an EC2 instance based out of Ubuntu. So I'm going to use this particular Ubuntu based machine for all of our activities. Okay, so just give me a minute, guys. I will be taking the, okay, sorry, I will be taking the, just a minute, I will be taking my command prompt in order to do that. I will be taking the commands in handy, so nothing much. Yes, guys, I just like shared my screen. So I think it is coming up. Yeah, yes, it's done. So, guys, now I'm in a SSH client. Okay, there is an SSH client called MOBA extern. So I am using that particular client in order to access with my Ubuntu machine. So, and this is the machine that I have created in my AC or AWS. I mean, this is an EC2 machine that I have created. So now what I'm going to do is that I'm going to do the installation of Docker. Okay, so this is the steps in order to do the installation of Docker. So as a first step, what I'm doing is that I am just updating the existing system. So the command to update the existing system means sudo apt update. So it will update my, or I mean it will update my existing machine, so with the latest packages. So that is what I'm doing now. Yes, so now it has been done. Okay, so now it has been done. So as a next step, what I'm doing is that I'm installing some of the prerequisite packages which are necessary for the Docker installation. Guys, this is the clear cut step and the verified step in order to do the Docker installation. So now it has been done. So now I have installed my required properties. And the third step, what I'm doing is that I'm adding the GPG key. Okay, which means, I mean, in terms of this AWS, we need to make use of this. Okay, so in terms of this AWS, definitely like we need to do this kind. Okay, so if you see, I have added my GPG key. And as the final step, what I'm doing is that I'm adding the Docker repository. So adding the Docker repository means I am telling this Ubuntu machine, so from where I need to download the Docker software. Okay, so I'm just like telling this particular what is it, I'm telling the Ubuntu machine, so to download, please Ubuntu, please go to this particular URL, and from there you can download the Docker. So that is what I just like did now. And as a final step, I'm installing the Docker CE. Here Docker CE means community edition. So we are having a lot of the enterprise version and all, but in this particular demo we are going with the open source for the learning purpose. So yes, I mean open source is fine for all, so you can easily use that. So now we are doing the installation of the Docker, so using this particular command. So let us wait for some time so that like it will be installed. Just a minute guys, so it will take some time. Okay, because like it once again it depends on the bandwidth of your internet. Okay, so if your internet is too fast, then you can easily download this. And now we have done the installation successfully. And now what we are going to do is that we are going to execute, or we are going to check the status of my commands. Okay, status of my Docker. So I have successfully installed the Docker, and now I'm able to see the what is the running status, I mean the active status of the Docker. So now we have successfully completed the installation, and now we are good to go with our own set of working. Okay, so now we are good to go with our own set of working. Okay, so now just I'm just like going to the PPT. Guys, I followed the same steps in the given what is the given material. Okay, so nothing much, I have not like done any new stuff here. So I followed the same thing for the installation of Docker. So once you have installed the Docker, okay, once you have installed the Docker, so what is the next thing we need to do is that we need to I mean, these are all the basic commands to check whether your Docker is working fine or not. So the first command which I'm going to run is that Docker version. So using this command, you can check the version of your Docker. See, we are having this, I already told, right? So there will be the client and there will be the server. So the client version is both the client version and the what is it, the server version is same, which means 20.10.14. And in the same machine will act as the server, the same machine will act as the client. Okay, so this is the command that you can execute in order to check the version. And in order to see the system wide information, you can go with this docker info command. Guys, these are all the basic commands that you can execute before going into the learning. So okay, so it will give you the system wide information. See, information in the sense, so whether you are having the what is the operating system, what is the kernel version of your host machine, and in terms of the server, so how many containers are running, how many images have been used. So these kind of activities you can, you these kind of information you can get it from the docker info. And the first one, so whatever the programming language or whatever the thing we will be learning in the IT industry, so the first thing we will be starting with the hello world. So in order to create the hello world container, the command to use is that run hello world. Okay, so this is the name here. So run hello world. So what it will do means, it will download this, it will down see, if you see, it will download it from the, I mean, it is checking in the local, so then it is downloading from the docker hub. That is what I told. So it will look into the local machine first. If the image is not in this local, it will download it from the docker hub. And if you see hello from docker, and this message shows that your installation appears to be working correctly. Guys, if you are getting this message only, your installation is successful. Okay, so this is the kind of hello world program. And so the next thing is that I already told, right? So this particular containers, okay, this particular containers is purely based out of the images. Okay, so with using images only, you can create this containers. So how you can search for the images? So this is the command actually. So docker search then image name. Okay, docker search then image name. So see, let us see, I'm trying with this ubuntu. Okay, I'm trying with this ubuntu. See, we are having these much of ubuntu images. See, ubuntu, websphere liberty, and ubuntu, sorry, ubuntu upstart. So likewise we are having a lot of things, guys, but you should consider the value of stars here. Okay, you should consider the values of stars here. So based on the number of stars, you can download this particular image. And in order to download that image, guys, like here we will be calling it as a pull instead of downloading. And in order to download your image, okay, in order to download the image to your local machine, you need to use this docker pull the image name. Here it is ubuntu. So docker pull ubuntu. If you see, it is downloading from the docker hub. So the, okay, this is how you need to download the images, guys. Okay, so now what I did is that in order to create the containers, I downloaded an ubuntu image at this particular stage. So now what is the next step is to, I can view the list of images in my local machine. Okay, so now just now I downloaded this ubuntu, right? So now I am running this docker images command, and if you see this ubuntu and hello world, and these things are in my machine. Guys, now I'm just like coming to the difference between the virtual machine and the container. If you look into the size of this ubuntu image, it is just 72 MB. But if you download the Ubuntu OS, it will be in terms of gigabytes. So please see the difference, I mean, in terms of the size. So this Ubuntu is taking only 100, I mean, some 100 MBs, within the 100 MB. But if you are going for that particular VM, so I mean virtual machine or the OS, it will take around gigabytes. So this is one of the primary advantages of going towards the Docker. So now what I'm going to do is that I'm going to create a container from this particular image. Okay, guys, this is the flow. So your image will be there. Okay, and from that particular image, you will be creating the container. You will be creating the container. So where this image will reside? So this image will reside in your local machine. If the image is not inside your local machine, it will download that from the Docker hub. Guys, this is the flow. This is the simple flow. So you will be creating the, you will be checking for the image. If the image is not in the local machine, first it will be downloaded from the Docker hub to the local machine, then the image and the containers will be created. So now what I'm going to do is that I'm going to create the, or I'm going to create the container. So Docker run it Ubuntu. See, guys, are you able to see the difference? So I created a container here. I executed this Docker run here. If you see my root, this particular root is the root of my host machine. But if you see this root at some different number, I mean some varchar kind of thing, E19C1. So which means we are inside the Docker container. So we are inside the Docker container. If you see the host name is the Docker container ID. So this is how you need to run the Docker. So I'm giving this exit here. So how you can view the list of Docker containers means these are all the commands. So Docker ps will give the running containers. Guys, this Docker ps will give the running containers, but our containers has been exited, so it will be in the Docker ps hyphen a. So if you see, this is, I mean guys, if you see this number, this E19096 and the last four digits 096C, so these two are same, which means my container has performed some task and that has been exited. So guys, how much time it took? It took only 2 to 3 minutes in order to work. I mean, sorry, it took some seconds in order to spin up the container and in order to delete the container. So that is the beauty of the Docker containers. Okay, so that is the beauty of the Docker containers. And now how I can, okay, so now this container is in the, this particular container is in the exited state, right? So how I can start my container? So using the Docker start command and the container ID. So now my container will be started. Okay, so my container will be started. If you see, it is up for 3 seconds, which means I started my container once again. Okay, and now it is time to look into some of the details of the container details. So if you see, this is the unique container ID that will be assigned to each and every container, and this is the image that has been used for this particular container, and this is the command which is which has been executed inside the container, and this is the timeline. So when it was created, when this particular container was created, it's 2 minutes ago, and this is the status, so whether it is running or got exited. And this is the names actually. So this is the common or the random name that Docker will assign to this particular container, and even if you are interested, you can give your own set of names. Okay, so how to stop the container? The same thing, you need to use the Docker stop the container ID. So it will stop the respective container. And the third thing would be, guys, now we have seen this, right? So now I'm running this docker run idt, but what it is doing is that it is closing my terminal and it is opening the containers terminal here, right? So now I'm in the container terminal. So in order to avoid that, okay, in order to avoid that, or in order to run your containers in the background forever, you need to go with the detach mode. So you need to use this either hyphen hyphen detach or hyphen hyphen d. So that is what I'm going to use it now. So hyphen it and hyphen d ubuntu. If you see, I'm not getting the prompt of my docker container, but I'm getting the same prompt of my host machine. So now if you see docker ps, my application or my new container will be up and running in the background. Guys, if you see the container id, so it will be the same f3eb and f3eb. So this is how you will be running the container in the detached mode or in the background mode. And guys, this is what these are all some of the topics or some of the commands that is used for the troubleshooting purpose. So docker ps will list the containers, okay, running containers. So docker ps hyphen a will show up all the containers. Okay, it will show up all the containers, okay, which means hyphen a means hyphen I mean all. And docker ps hyphen l will give the I mean recently created. So this is the recently created container, so it will give the recently created container here. And the I mean in order to inspect, okay, in order to inspect about a container, you can use the docker inspect command. Okay, you can use the docker inspect command, and you need to put the container id here. If you see, if you give this docker inspect, you are getting a lot of information about that. See, I mean whether it is in the running state, and when it has been created, and what is the image that has been used, and what is the ip address assigned with this particular one. So likewise, you will be getting lot of information about this particular container. Guys, you need to use these images for the troubleshooting purpose. And the docker top, okay, there is a command called docker top. So this command will help you to see the processes running in your container. See, this is the process. Okay, these two are all the process. Okay, let me open in this. Yeah, so this is the process running inside this particular container. So guys, these are all for the troubleshooting purposes. Okay, and this command, this docker logs container id, is to see the logs generated or the logs created by the container. So I hope like you won't get any logs associated with this, because this container has not created any logs at this particular stage. But using these commands only, you can do the troubleshooting. And so the finally we are jumping into this, the data persistence area. So the data persistence in the sense, so whatever what these docker containers are ephemeral actually. So ephemeral in the sense it cannot persist the data. For example, if I'm creating a container here, okay, let us say I'm creating a container run. Okay, so let us go with this. If I'm creating a container here, I'm creating a sample file. Okay, I'm creating a sample file. So sample.txt. Okay, so now the sample.txt will be there. But if I exit from this particular container, so my container will be terminated and my sample.txt will be deleted. So there won't be any persistence of data. See, you are not able to see the sample.txt. So in order to do the persistence of the data, we are having two options. So first one is volumes, and the second one is the bind mounts. So volumes are nothing but you will be storing the files as the host file system. Guys, this is something similar to the shared drive. Okay, so in terms of Windows, we will be having the shared drive, right? So you will be storing that some files in the common shared drive or common server. Even if you restart your Windows machine, so that file will be available in your shared drive. So the same analogy applies here. So the first option is called volumes, and the second option is called bind mounts. So volumes are nothing but it will act as a part of the host file system, and in terms of bind mounts, you can refer a file or you can refer a directory. And guys, this is how like we are going to do. Okay, this is how we are going to do this. Okay, so that is what I did now. So I'm going to run this particular, okay, I'm going to create a new container. Okay, so that is what I told. Okay, I created a new container, then I created the example. I created a file called sample.txt here. So now I'm able to see this txt, okay, the sample.txt in this particular one. But if I exit from this container, so my container will be deleted or terminated. So in that case, my sample.txt will be deleted forever. So in order to do that, what we are doing is that we are using the concept called volumes. So here what I'm doing is that as the first step, I am going to create a volume, and the command to create the volume is that, guys, this is a kind of like persistent storage. Okay, you are creating one content, you are creating one volume or the space, and you are just like adding that with the, you are just like mapping that volume to the running container. So that is the concept here. So what I'm doing is that I am creating a sample volume. Okay, so I'm creating a sample volume using this directory. So my volume has been created. So docker volume ls, so that is a, it is a local, and a sample volume has been created. So now what I'm doing is that I am attaching this particular volume with the respective container. So what I'm doing is that I'm doing the mapping. So using the command -v, so -v stands for volume. So sample volume, then I'm where I'm just mapping, I'm mapping to the temp directory. Okay, I'm mapping to the temp directory and Ubuntu. Okay, this is the container that I'm going to create. See guys, like what I'm doing is that, so I'm creating a container here. Okay, I'm creating a container here from this image, but what I'm doing is that I am mapping this sample volume. Okay, I'm mapping this sample volume directory to the temp directory. Okay, you can map it to any directory, but here I'm mapping this to the temp directory. And now if I run this, okay, so now my container has been created, and now I'm going to enter into this particular one. Okay, hyphen it and the respective container and the bin bash. Guys, this is the way that you can enter into the container. Okay, so now I'm inside the container. So now I'm going into this temp directory. So here, if I touch sample.txt, okay, if I touch this sample.txt, a sample.txt file will be generated, and that same file will be into my, okay, and same file will be what is the persisted. Even if I delete this particular volume, okay, even if I delete this particular volume, it will be present in my local machine. Okay, so it will be present in my local machine. So that is the purpose here. Okay, so now I have created a sample text inside my container. Okay, I have created a sample text inside my container. Now I'm doing this exit. So now I'm going for this docker inspect my volume. Okay, so my volume will be there, right? So docker volume inspect in order to find the data or find the path where it has been stored. Okay, so inspect sample volume. So my data is here. So my data is here. So if I go to this particular directory, you will be able to see the sample.txt. So even if I delete my container, okay, this even if I delete this particular container, my data will be persisted forever in my local machine. So this is the concept of persistence, guys. Okay, so I have not done anything. Okay, so I created a volume, I mapped that particular volume to the temp directory, and I created some files in the temp directory, and that particular temp directory, okay, I created this particular temp, some files in the temp directory, and that file has been created automatically in my local volume. So even if I delete this particular container, okay, so docker ps, so it is running, okay, so it is running there, this is the container, right? So it's 3a 3a, so this is the container. So even if I docker rm, okay, so if I run this particular one, so docker, it will be asking for the force, so I can give this hyphen hyphen or so even if I delete this particular container, see only one container is running, I will be having my sample.txt. So this is the concept of data persistence, guys. Okay, so this is the concept of data persistence. Okay, so I mean, if you are having any doubts, yeah, so you can please feel free to like post that in the chat window. So the common understanding is that if you are creating a normal container, that will be ephemeral or not temporary in the temporary in the stage. So if you want to persist, or if you want to save the data that has been created inside the container, you need to make use of this volume concept. So that is the point here, guys. Okay, so it's nothing much, so it's something very simple actually. Okay, so the next thing would be the port forwarding. Okay, so what is the purpose of this port forwarding? In the sense, it is the process of, okay, making your, okay, it is the process of redirecting a communication request. For example, this particular port forwarding means you will be able to access your docker containers from the outside environment. So as of now, whatever the docker containers we have seen, so we cannot like access this from the outside environment, I mean, which means the kind of web application. But if you see this particular one, okay, if you see this particular one, using this port forwarding, we can make the external clients or the users to access our application. Guys, this port forwarding is for, okay, so this I'm taking some of the running notes for your better understanding. So port forwarding is nothing but you are hosting an web application. Okay, you are hosting a web application in a docker container. Okay, this is the scenario, in a docker container. So how you will make the external users, okay, how you will make the external users to access this web application? That is the concept here. Okay, how you will make the external users to access the web application. So that is the concept here. So that is what we are calling it as port forwarding. So here in terms of port forwarding, we are having two options. So one is publish all and one is publish actually. So hyphen publish all means it will publish all the exposed ports to the some of the random ports. Okay, so you will be having, we will see the demo for this. Okay, but in terms of this hyphen, guys, please understand, this is a low uppercase hyphen p and this is the lowercase, so which means this is publish all, this is publish. So what we will be doing is that we will be using the docker port. Okay, we will be using the docker container port to map with the host port. Okay, so we will, docker container will be having some port and we will be mapping that with the host port. So that is the concept that we are doing here in terms of the port forwarding. And guys, this is how we need to do. Okay, so now what I'm going to do is that I'm going to see, I'm having a Windows machine. Okay, I'm having a browser here. Okay, I'm having a browser here. So I need to access my container which I'm creating here using this browser. So how can I access that? So the only way is that I need to use this particular command. So what I'm doing is that docker run, okay, I'm using this docker run hyphen it hyphen d and hyphen p. So what I'm doing is that I am exposing the port number 8000, okay, to the port number 80. So this is okay. What is the name I'm giving here? It's an nginx. Okay, so name I'm giving it as web server, and the image which I'm going to use is this nginx. So if you see, I'm just like taking this for your better understanding. So what I'm doing is that I'm running in a normal way, so hyphen id idt, but what is the extra thing I'm adding here is the hyphen p 8080, and the name I'm giving, I mean, this is how you can fix the your own set of name. Okay, so here I'm using this hyphen p 8080, the name server. So I'm going to run this particular command. So let us see. So it is downloading the nginx image, and see, I mean, if your internet is too fast, so you can easily download that within some time. Okay, so now I'm doing this docker ps, I'm doing this docker ps. See, a new container has been created, and the name of the container is web server. And if you see, it is doing the port forwarding. So you, I mean, I can, this nginx is running in port number 80, guys. This nginx is running in port number 80, but how I can access this 80 means using the port number of 8000 from my local machine, and the machine which I am using now is the EC2 instance. So what I'm going to do is that I'm going to open my security group. Okay, I'm going to open my security group for this particular demo alone. So the port number which I'm going to use is 80, and I'm going to use this anywhere from IP, so anyone can access this. Okay, even if you guys are like in front of the machine, I mean, I hope you guys are like in front of the machine, so even you can use this particular public IP and give the 8000, so you will be able to see the nginx. So this is how you need to do the port forwarding. So what I did is that I downloaded the image of nginx, so that nginx image is running in 80. So what I did is that I cannot directly access this 80, so I did the port forwarding of 80 to 8000 of my local host machine. So using that particular 8000, I'm able to access my machine here. So I'm able to access my nginx here. So this is the concept of port forwarding, guys. Okay, this is the concept of port forwarding. And in terms of lowercase p, I'm specifically mentioning the respective port number, but in terms of this uppercase letter p, it will automatically assign some random ports. That is the small difference between this hyphen p. Okay, so now what I'm doing is that, okay, so now just give me a minute. Okay, so we are having only some little bit of things, so that like we can have a good amount of time for the Q&A session. So this, I mean, the next demo would be how to create the docker image, okay, using the docker commit. Guys, actually there are two ways. Okay, there are two ways to create the docker images. So using docker commit and using the docker file. So using the docker commit you can create the image, and using the docker file you can create the image. The first step which we are going to see is the docker commit. So what we are going to do is that, so I mean, okay, that, I mean, the basic difference is that this docker commit means you will download the existing image and you will do some changes on top of that particular image. Okay, that is the docker commit. But in terms of docker file, you will be creating a new image from the scratch. Okay, so that is the purpose here. So you will be creating the new image from the scratch. So that is the small difference between this. So now what I'm going to do is that I'm going to follow the same commands here. Okay, so I'm going to follow the same commands. So guys, let me stop this particular container because it is a kind of security breach. So let me close this port because this is a security breach for me. So if I just open this particular port, then yeah, okay, yeah, cool. So now what I'm going to do is that I'm going to follow the same command here. Okay, I'm going to follow the same command here. So I'm going to use this docker pull Ubuntu. So Ubuntu is already there, so it won't take that much of time. Yes, docker pull Ubuntu, and I'm enter into this docker run. I'm running a container here, docker run hyphen it and the Ubuntu. Okay, sorry, it is a typo. Ubuntu, a container has been created and I'm entering into that container. So docker exec hyphen it, the container ID and the bin bash. So I have entered into this. So now what I'm doing is that I'm installing something into that. So apt-get update I'm running inside this. So it is running there and I'm installing a software. So apt-get install Apache 2, which is nothing but the web server. So I'm making this particular Ubuntu container as an Apache web server. So because I need this particular image for my own purpose. Okay, so now I'm giving this option 6 Asia, and here I'm just going with this add-on, so nothing much. Okay, so now what I did is that I pulled the image, I created the container, I entered into the container, and I did some changes, which means like from the base Ubuntu image, I added my own changes on top of that. So now what I'm going to do is that I'm going to exit from this container and I'm going to run this docker commit statement. Okay, I'm going to run this docker commit, the container ID and the username of your, okay, and the username of your respective, okay, okay, let me do with this. Okay, steady 9 called Santosh NC. I'm making this image name as steady 9 demo. Okay, I'm making this image name as steady 9 demo. Okay, so now a new image will be created on top of this. If you see, if I run this docker images, you will be seeing a new image called Santosh NC steady 9 demo, which was created 5 seconds ago. So now as the next step, okay, this is how you can create the images. Okay, so this is how you can create the images using the docker commit. So the next step is to create the docker images from the docker file. Guys, like now if you see, I have executed each and every instruction in a manual way, right? So I executed this pull, I executed this container, and I executed into that, and I updated something, installed Apache. So all these things actually I did in a, what is it, manual way. So each and everything I executed in a manual way. So now this docker file allows us to write a file. Okay, this docker file option allows us to write a simple text document which all the contain with all the respective commands in order to create the image in an automated way. So that is the concept of docker file. And here in terms of docker file, we will be using some of these instructions, guys. So from it will use to define the base image, and add, it will use to copy or add the files to the image, and there is a command called run and cmd entry point env. So in addition to these instructions, we are having other set of instructions as well, but these are all the basic or the common instructions that we are going to use here. So from defines from where I need to take the base image, and add means it will help us to add or copy the files, and run means it will use to run the particular okay, it will use to run the commands or some of the instructions inside the image. So command means it will use to execute the commands at the start of the container. Guys, this command and entry point will do the same thing. Okay, but this command can be overwritten, and this entry point is won't accept any arguments. So that is the small difference in terms of this command and entry point. And n, it's a kind of like self-explanatory in order to define the environment variables. So now I'm going to create the okay, so now I'm going to create the container, okay, based on this particular file. Okay, I'm going to write the file here. Okay, so let us see. I'm going to write the file here, so nothing is there. So guys, the naming convention is important. Okay, the naming convention is important here. So vi docker file. So I'm going to write the same thing. So from, because like I created from the Ubuntu image only, right? So from Ubuntu, and guys, just a minute. I can copy this from my own machine. Okay, so I'm having the contents in handy, so I don't want to type this for the, what is it, for the betterment or in order to save the time. Yeah, let me share my screen. Yes, I shared the screen, and yeah, so now you are on the screen. Yeah, so I copied the particular content here. So I'm going to use the same thing here. Okay, so webinar. Okay, see, this is what actually we are doing here. Okay, so I'm just like giving I and I'm deleting this. So the same thing. If you see from Ubuntu, and these two things are in order to set up the time zones, and this apt-get, then Apache 2, and add something, and the entry point. Okay, so if you see the command, if you see this particular command, I did the same thing here. Okay, if I'm just like going in the split screen mode. If you see, the first step I did is downloading the images. I'm doing the same thing here. And the next thing, I'm creating the container, but this building of the images will create the containers by its own. Okay. And the third and fourth step would be running the apt-get update, install Apache 2. And I'm doing the same thing here. So run apt-get update, run apt-get install Apache 2. Then this entry point and add, so we'll do some specific things, and this entry point is used to start the Apache service. So once you have installed this, you need to start the Apache service, right, in order to host your web application. So that is the purpose of this entry point. Okay, so now what I'm going to do is that I'm going to use this particular command. If you see this particular command, this is the command used to build the Docker image. So you need to be in the respective directory, so where your Docker file resides. So my Docker file is there. So now I'm running this Docker build dot refers to the current directory hyphen t and your new name, and your new name should be Santosh NC slash steady 9 demo 2. Because why this is important means, this tagging is important means, then only you can be able to push this image to the Docker hub. If you are having this kind of thing, you cannot like push this to your own account. So based on this name only, it will be identified based on your account name. So see, now I'm going to build the image. See, it is building the image, right? So it is building each and every bit, it is doing the each and every step. See, so step 1, step 2, step 3. So whatever the commands we have entered, it is doing each and every step here in terms of layers. Yeah, so it will take some time. If you see this Docker images, so you will find two images. So Santosh NC Study 9 Demo 2 and Santosh NC Study 9 Demo. Guys, this is how you need to create the images. Okay, this is how you need to create the images. So the next step would be you need to push this particular image, right? So okay, how you can share this particular image with, okay, now I have, okay, now Santosh myself has created two images for my own project. So how I can share this image with my project mates? So that is why we are having this Docker Hub. So in order to pull, or in order to push this to the Docker Hub or upload to the Docker Hub, so it will be useful for us. So the first step that I need to do is that Docker login. So my account, Docker Hub account in prior. So that is why I'm already having that. So I'm entering this, the username, password. Sorry, username is Santosh NC, and password I'm typing here from my end. So now login succeeded. So the next step would be I will be pushing my Docker push and the respective name. So Santosh NC Steady 9 demo 2. So I will be pushing this particular image. Okay, and it is pushing that. Okay, so let us see what is happening. So I'm pushing that particular image to the Docker repository or the Docker registry or the Docker hub. So now it has been successfully done. So now I'm entering into this Docker hub. Now I'm entering into this Docker hub for this. So this is the URL for the Docker hub, guys. Okay, so hub.docker.com. So here you can go for the explore even without entering. So now I'm just like typing this Santosh NC study 9. You will be getting the, okay, okay. Sorry, I just like typed this wrong one. Okay, okay. So we are not having new. Okay, let me sign in. Okay, so here if you see under my profile, see, I'm having a latest image which I have pushed some time back. So Santosh and see study 9 demo 2. So this is how you can upload the contents, and this is how you can push the images to the repository, so to the online repository. And if you want to use this particular file, you can use this particular command. So docker pull Santosh and see study 9 demo 2. So likewise I can be able to push my another image as well. So study 9 demo. So it will be also pushing the same thing. See, it is trying to upload, it is uploading that. So let us wait for some time. Yeah, so now it has been successfully uploaded. And now if you see my image, I mean the registry, see, I'm having study 9 demo as well as my study 9 demo 2. So this is how you can create the image, create the container, do the changes, create the image on top of that, then you can upload that to the Docker Hub registry. So that's all actually from our end, guys. Like, thank you for listening and thank you for attending this particular session. And now, yeah, it's time to have a Q&A session for the next 10 minutes. So if you guys are having any questions at this particular stage, yeah, please post that. And yeah, Pranana, like, over to you. So you can just like take it further. Like you can just like give me the questions so that like I can do that, or I can answer those questions.
Hello.
Yeah, you are audible.
Yeah, yes, sir. So now we have question from two people.
Okay.
So we have one question from Viraj. He's asking about what is ephemeral. Ephemeral.
Okay, okay.
Yeah.
So actually, like ephemeral in the sense it is a temporary. So ephemeral, the exact meaning for this ephemeral is not persistent or temporary. So this Docker containers are actually ephemeral in nature, Viraj. So that's why like I gave that particular answer. Yeah.
Yes,
Yes,
sir.
sir.
We have next question.
Yeah.
So for accessing any application running inside Docker, we have to open port in virtual machine configuration, like you did in EC2. Is it so?
Okay, so for accessing any application, yes, Rog. Okay, so this question has been posted by Rohan, I guess. Yeah. So yes, so we need to open the port in the virtual machine because you might be having a firewall behind. Okay, your virtual machine might be behind the firewall or security groups or knuckles, but how you can like expose your internet, or how you can expose your port to the public in order to access that. So in that case, you need to do the port change, or you need to do the firewall settings change, or the virtual machine configuration, or the host machine configuration.
Our next question is from Viraj again. In real would professional work, which one is more preferred, Docker commit or Docker file? And also tell us about common interview question.
Okay, so I'm answering the first question. So in terms of the real world scenarios or in the IT industry, the people will be using this Docker file actually, because you can track the changes in terms of the Docker file. But if you follow the Docker commit, you can't track the changes. So Docker commit is not suggested or the preferred way. Docker file is the preferred way to create the Docker images in the real time environment. And I'm taking the next question, so which means like the common interview questions, right? So the common interview questions, in sense you will be asking about the setup. I mean, the you will get a question in terms of the Docker components. Okay, so what is the difference between image and the container, and what do you mean by this Docker hub, and some of the basic commands related with the Docker, how you can create, and what are all the multiple, what are all the best sources, or what are the best practices in order to implement the Docker file. And the common question will be the differences between the instructions actually. So we have seen about the instructions, right? So this instruction set from add, run, command, entry point. So you should be very clear in terms of this particular instructions files. Okay, what this from will do, what is the difference between this run and command and entry point, and what is the difference between this add and copy. So these kind of real time scenarios you will be real time questions you will be getting.
Okay, sir. Now it's time to wrapping up. So thank you for your wonderful session. Throughout the session, it was wonderful, and I would like to thank all the attendees for attending this session. And now I would just like to tell you all that next Sunday we have another interesting session. So make sure you like and subscribe our channel to get the updates. And now I'm ending this session. So thank you, everyone.
Thank you all, bye bye.